In the remote expanse of northeast Siberia, a geological marvel is rapidly taking shape. Locals call it the doorway to the underworld. Scientists know it as the Batagaika crater. This massive depression in the Earth's surface is a stark reminder of the power of our planet and the impact of human activity. The crater is a growing chasm, stretching almost a kilometer wide and reaching depths of nearly 100 meters. Its growth is a cause for concern as it offers a glimpse into the potential consequences of climate change. The Batagaika crater first appeared in the 1960s. Its emergence was linked to deforestation in the region during that time. The removal of trees exposed the ground to more direct sunlight. This increased the ground temperature, which had a devastating effect on the permafrost layer beneath the surface. Permafrost is a layer of soil, rock and ice that has remained frozen for at least 2 years. It acts as a giant freezer, locking away organic matter for millennia. However, as temperatures rise, the permafrost thaws and the once solid ground transforms into a muddy, unstable mess. The thawing permafrost has had a profound impact on the landscape, leading to the formation and expansion of the Batagaika crater. As the ground thaws and collapses, it creates depressions in the earth. These depressions then fill with water, forming thermokarst lakes. The edges of these lakes are particularly vulnerable to erosion, and as the permafrost continues to thaw, the lakes grow larger and the surrounding land collapses further. This process, known as thermokarst, is responsible for the dramatic expansion of the Batagaika crater over the past few decades. The crater's growth is a clear sign of the changes occurring in the Arctic region. Siberia, in particular, is warming at a rate twice as fast as the global average. This accelerated warming is amplifying the effects of climate change, leading to more rapid permafrost thaw and the expansion of thermokarst features like the Batagaika crater. The implications of this phenomenon extend far beyond the immediate vicinity of the crater. As the permafrost thaws, it releases massive amounts of greenhouse gases into the atmosphere. These gases, primarily methane and carbon dioxide, have been trapped in the frozen soil for thousands of years. Their release into the atmosphere contributes to the greenhouse effect, further accelerating global warming. This creates a dangerous feedback loop. Warmer temperatures cause more permafrost to thaw, releasing more greenhouse gases, which in turn leads to even warmer temperatures and more permafrost thaw. The thawing permafrost also poses a significant threat to infrastructure in the Arctic. Buildings, roads, and pipelines built on permafrost are vulnerable to damage and collapse as the ground beneath them thaws and becomes unstable. This is a growing concern in Siberia and other parts of the Arctic, where much of the existing infrastructure was built without considering the potential impacts of permafrost thaw. The environmental consequences of the Batagaika crater's growth are multifaceted and far-reaching. Beyond the release of greenhouse gases, the thawing permafrost also impacts local water systems. As the ground thaws, it releases pollutants that have been trapped in the frozen soil for decades. These pollutants, including mercury, arsenic, and other heavy metals, can contaminate drinking water sources and harm aquatic life. The increased sediment load in rivers and streams due to erosion can also negatively impact fish populations and other aquatic organisms. The changing landscape also poses challenges for local communities that rely on the land for their livelihoods. The disappearance of permafrost makes it difficult to build and maintain infrastructure, and the thawing ground can release pollutants that contaminate traditional food sources. These changes are forcing communities to adapt their way of life, posing cultural and economic challenges. Despite the alarming nature of the Batagaika crater's expansion, it also presents a unique opportunity for scientific research. The exposed layers of permafrost provide a valuable archive of past climates and ecosystems. By studying these layers, scientists can gain insights into how the Earth's climate has changed over time and how ecosystems have responded to those changes. The crater's depths hold secrets to a time when woolly mammoths and other extinct creatures roamed the Earth. Fossils of these ancient animals, remarkably well preserved by the permafrost, provide valuable clues about the past. Scientists can analyze the DNA from these fossils to learn more about the evolution and extinction of these creatures. The crater also serves as a reminder of the interconnectedness of Earth's systems. What happens in the Arctic doesn't stay in the Arctic. The thawing permafrost and its consequences have global implications, highlighting the urgent need for collective action to address climate change. The Batagaika crater, a scar on the Siberian landscape, serves as a potent symbol of the challenges and opportunities presented by a changing world. Understanding its creation, growth, and potential impact is crucial for navigating the complexities of a warming planet and ensuring a sustainable future for all. As we continue to explore the mysteries of the doorway to the underworld, we gain valuable insights into our planet's past and a deeper understanding of the challenges that lie ahead.